All right, today we are doing 0-1 sets. Today's date is today. And our objective, we're going to use the set notation to denote elements, subsets, and complements. Well, in reality, we're going to be talking more about the properties of numbers. So let's talk about some property names and what it means. The commutative property, it just doesn't matter the order. A plus B equals B plus A, that's the same as saying 1 plus 2 is 2 plus 1. Same thing with multiplication. This does not work for addition or subtraction. Associative, it doesn't matter how you group them together. 1 plus 2 plus 3 would be the same as 1 plus the sum of 2 and 3. Identity, it's going to be equal to itself. There is no change. Inverse, that's the opposite or the reciprocal. When you add inverses, your outcome is 0. When you multiply reciprocals, it's 1. In the multiplicative property of 0, anything you multiply by 0 is 0. And the distributive, whatever's on the outside of the parentheses, you multiply with what's on the inside. This is really just the same thing. It's just giving it to you in some different words. If you're taking notes, you might want to pause and just read it. So what I would suggest you do is take a second and look at these and try and answer them on your own. Pause your computer, answer them, and then we can check them in just a second. And there are your answers. Again, you might want to pause if you need to check them a little bit longer. So again, try and do these on your own. You want to name the property shown. You might want to go ahead and pause because not everything is going to be shown here. I do 1 through 7 first. And then here is 14 through 16. I will show the answers in just a second. And there are your answers. All right, types of numbers. The number system is divided up into two main parts, the real and the imaginary. We'll talk about the imaginary later. Right now, it's the real number system. And that is going to be your big square here, because there's subsets then to that real. The real includes either irrational, irrational, or rational, which includes integers, which can be whole numbers, which can be natural numbers. Natural numbers, it's kind of hard to see that, but they're going to start counting 1, 2, 3. No negatives, no 0. Whole numbers start at 0. 0, 1, 2, 3, so forth. Integers is everything that you would see on a number line. Now we're going to start including the negatives. -1, -2, 0, so forth. Rational numbers. A rational number is anything that can be expressed as a fraction. Anything that can be expressed as a fraction is a rational number. An irrational number is a number that repeats, or I'm sorry, a number that goes on forever and ever and doesn't repeat. So 1/3 goes on forever and ever, but it repeats a pattern. Radical 2 goes on forever and ever, and it does not have a pattern. Some other irrational numbers are pi and e, but those are also real numbers. Real numbers kind of encases everything. All right, I hope you enjoyed. Have a good day.